when you multiplied, oops, sorry.
There's like other pages.
It is not my stuff. Maybe check with, it would either be Miss Polinsky or Miss Kaylaw, but it is not mine. Thank you for checking. Okay. What did you notice when you multiplied these together? Interesting. So Dot noticed that 7 is 3 plus 4. 5 is 2 plus 3. 6 is 1 plus 5. And 10 is 4 plus 6. But then 4 times 6, 1 times 5. Do you see that? Anybody else notice that? Yeah? You notice that? Okay, so what do you notice here?
Is that basically
Joey?
basically you're subtracting, like you can see the 3 and the 4.
Yeah.
Subtracting to be 7, -7.
Ah.
And then you can see that the 3 times the 4, there's a 3 times the -4 and the positive 12.
So do you notice how these two are the same, just except this sign right here? Did you notice that?
Yeah.
Okay. Interesting. So like this was like x plus 3, x plus 4. This was x minus 3, x minus 4, right? Okay, well then what happened when one was plus and one was minus? How did that affect it?
Well, it made it so that way you have it. Like if you look on the first one, you can see that you have the -3 times the positive 4 and the -12.
Okay, so we still have the times to get to that last, okay.
But if you do -3 plus the 4, you get positive 12.
Okay, so do you notice what Dot said about the first one? Does that still work? What is -3 plus 4? 1. What is 2 plus -3? -1. What's -1 plus 5? And isn't that interesting? Okay, so how many of you figured out that this was x plus 5 times x plus 2? How many of you figured that out? Okay. How'd you figure that out, Aubrey? Like, what was your thought process?
I just plugged numbers in until it worked.
Okay, Aubrey plugged numbers in until it worked. Willow, was that your strategy? Yeah, okay. Theo, did you have a strategy that's different?
Yeah, I just kind of thought that they're going to have to be multiplied and added to the numbers.
Okay. So some of us have noticed that, okay, we need to add to 7, multiply to 10. Okay. It ends up that this is x minus 5 and x minus 2. It ends up that this is x minus 5 and x plus 2. For those of you who did try it out. Okay. If you didn't figure that out, that's not a problem. Okay. But this is what we're working towards today. Okay. Last week, I had you multiplying binomials together. Well, now I'm going to give you this, and we're going to go backwards, okay? This is what we call factoring, okay? So what I'd like you to do is get out your student journal, turn it to page 226, and we'll talk about that observation. Why does it work that we're adding and multiplying to get those cool numbers?
I'm asleep right now. I just got off the phone.
All right. Now, when we take two binomials and we multiply them together, we've been using FOIL, okay? So like right here where it says FOIL, right, we know what that means. If I have x plus 2 times x plus 3, we know we get our first, outside, inside, last, okay? Well, every time we have something that looks like this, except maybe maybe we have different numbers, okay? The O and the I are always going to add together when we combine like terms. Do you see what I'm saying there? The outside and inside are always going to add together to be that middle term, okay? So we're going to use that to help us factor, okay? If we are given a polynomial, or a trinomial, right? There's 3 terms, okay? This is going to be the first. This is going to be the O and the I together, and then this is going to be the last. So when we do our foiling, we need 2 numbers to multiply together to be 5. But then the O plus I, they need to add together to be the 6. Okay, so what multiplies to 5 and adds to 6? 1 and 5. Okay. If we look at this here. What multiplies to 5 but adds to -6? Well, -1 times -5 is going to give us a +5, but then they would add together to be -6. Okay? So when this last term is positive, our numbers are both going to be positive or both going to be negative. How am I going to know which one? Okay, if this guy's positive, they're both positive. If this guy's negative, they're both negative, okay? So let's look at a couple examples like that, okay? Could you write this down with me? Could you write down x squared plus 9x plus 18? Okay. Now, I'm going to write some words down. You decide whether you need to write these words down or not, okay? But this is what we're thinking in our head, okay? What 2 numbers multiplies to 18 and adds to 9? Okay, what 2 numbers multiply to 18 and add to be 9? Okay, so I'm going to just start thinking about numbers that multiply to 18. 1 times 18, 2 times 9, 3 times 6. I think that's it. Which set of numbers work?
6 and 3.
Okay, so I'm going to write x plus 3 times x plus 6. How do I know if I'm right or not? How could I maybe figure that out?
Well, you can maybe see, you could add the 3 and 9 and see if it equals the 9x.
Okay, even a little bit more than that.
You can multiply both.
Ah, we can FOIL. We can multiply it out. We could actually do the FOIL and make sure we get back to what we started with. You should be able to check your answer every single time on these, because we can just FOIL, multiply out to figure out if we got it right. Okay. Okay, let's try this one. We'll do blue. Okay. X squared minus 9x plus 20. Well, since this is a positive and this is a negative, then our outside and inside products need to both be what? Negative. Okay, so I am looking for two numbers that multiply to 20 and add to negative 9. So we're multiplying to 20 and we're adding to negative 9. Okay? So numbers that multiply to 20. 1 and 20, 2 and 10, 3, 4 and 5. Hold on one moment. Think about it. Okay. Who are you looking for? Oh. Okay. Okay. Maybe in a little bit. Okay. Somebody besides Joey, because I know Joey has it, but I need to hear somebody else's voice today.
Why you hate my voice?
I already have heard Theo's voice plenty too.
Why you hate my voice?
Zoe. What kind of 4 and 5? So x minus 4 and x minus 5. Do we agree?
Yes.
Okay, there's our answer. If we want to check it, we can multiply out. We can FOIL out.
But the smallest number always happens, or maybe the
You know what? That's a great question. If you write the answer x minus 5 times x minus 4, that is the same thing. Remember, multiplication is a commutative property. It can go in either order.
same with addition.
So I don't care what order you have them in. I'll be cool either way. Okay. All right. Now, let's talk about this situation. If our constant is negative, okay, that means we have one negative, one positive. If I'm looking for something to multiply to a negative number, that means I need one of each sign, okay? So here we're looking, hey, what multiplies to a negative 5 but adds to be negative 4, okay? So if I make 5 negative and 1 positive, that's going to satisfy that adds to negative 4 multiplies to negative 5, okay? So when that third term is negative, we just have to be a little bit more careful, okay? Let's talk about one, okay? So x squared plus 5x minus 14. Okay, we are looking for two numbers that multiply to equal negative 14 and adds to equal a positive 5. Okay, so I'm running through my head. What multiplies to 14? 1 and 14, 2 and 7. Darn it, that's it, right? Okay, of those two choices, what's the better one? Okay, so we know 2 and 7, right? But since one needs to be positive and one needs to be negative, and we have a positive 5x, Theo, which one needs to be positive? 7 needs to be positive, so when it adds to negative 2, we get 5. Okay. This is like a math puzzle. Some of you like math puzzles and some of you don't. You don't have to tell me your stance. I personally love math puzzles and I really enjoy factoring. Okay? I like thinking about what numbers make this work. Okay? Let's do one more together and then I might have you do a couple without me. Okay? X squared minus x minus 12. Okay. Anytime our constant term is negative, we know we're going to have one negative and one positive number for our O and our I. Okay, so I need two numbers that multiply to negative 12 and add to be negative 1. Can we all agree that that's a negative 1? Okay. So 12. 1 times 12, 2 times 6, 3 times 4. Okay. Connor?
Is it x minus 4 times x plus 3? That's what I was thinking.
Minus 4
Yeah.
plus 3.
Yeah.
Okay. Do you agree? Okay, I don't really hear a yes besides Theo, so let's FOIL it out. We get x squared plus 3x minus 4x minus 12. Do we do it right?
Yeah.
Okay, good. Thank you. Okay. So, go to the extra practice page. I'm going to highlight a couple problems I would like you to do. I would like you to do number 1. Number 3. Number 7. And number 9. Do those 4 and then we'll chat. And it's cool to consult with your neighbor.
Looks like your elbow bone.
That was pretty close. Almost biffed it there. Hmm? Okay. All right. Eliza, what do you have for number 1? Does anybody disagree with Eliza? Okay. Eva, what about number 3? Okay, any disagreements there? Okay. Number 7, let's see. Willa. You're still working on it? Okay, so Willa, we are thinking of numbers that multiply to negative 54 and add to 3. So I'm just going to start making a list of numbers that multiply to 54. And Willa, you just tell me if you think of anything. All right, Willa. Okay, and which, are they negative, positive? Hey, let her do it.
Oh, cheating.
Positive 9 and negative 6. All right, do we feel good about that?
How many acres?
All right, and then number 9. I was going to call on you, but you're playing tic-tac-toe instead of actually doing the problem. Tinley, what do you have?
U plus 6, U minus 6.
All right, how do you feel about Tinley? Yes, no, maybe so?
Yes.
Okay. Now, do you notice what I did, like, on number 7, okay? When we were, like, maybe struggling to come up with, I just made a list. I started with 1, moved to 2, moved to 3, moved to 4, moved to 5. I made lists of the factors of 54 to help me think, okay? Do that, okay?
Smaller ones before you go to like you're gonna pick like ones like 3, 4.
Well, not necessarily, okay? I would just start at 1. If it's even, go to 2. If it can, 3. Start making a list until you meet in the middle, okay? And then you can start picking from there. Now, go ahead and turn to the next page, okay? The purpose of factoring is so that it can help us solve an equation. Do you remember, right? I had you solve equations on your quiz yesterday, correct? Okay. Well, yesterday they were already factored for you. Today, we got to actually do the factoring. Okay. So I have a trinomial. It equals 0. So let's go ahead and factor it, and our factors will equal 0. So I need 2 numbers, please do not blurt, that multiply to a positive 40 and add to a negative 13. Please do not blurt. Please just think. Okay, here's my list of numbers that multiply to 40. Emily, which 2 do you think look pretty good?
5 and 8.
5 and 8. And what kind of 5 and what kind of 8?
Negative 5 and positive 8? Or negative 8?
Yep. So they're both negative because this 40 is positive, but the 13 is negative. Okay. All right. So now this looks like a problem from your quiz yesterday. Oh, hey, I have 2 factors that equal 0. So g minus 5 equals 0 and g minus 8 equals 0. So we can say, okay, well, g equals 5 or g equals 8. Okay. It's just one step past. You try number 15. Derek, do you know what our factors need to be? Could you tell them to me? What? 2 and 5. And what kind of 2 and 5 do we need inside of our factors? They're both negative. So we have 2 minus W. Ugh. W minus 2 and W minus 5. Okay? That's how we are going to get the minus 7 and the plus 10 right there. So if we set these equal to 0, everybody, W equals, and W equals, okay. Okay, you guys are fading on me fast here. Now, ooh, what do you notice about number 16?
The value doesn't equal 0.
Oh, this does not equal 0. So, before we can factor, what do we need to do with the 30? How so? We need to subtract the 30 over so that now we equal 0. We have a trinomial that we can factor. Okay? Here's the deal. If we are going to write a multiplication problem, that's what factoring is, okay? We only have the 0 product property. We don't have the 1 product property. We don't have a 30 product property. We only have the 0 product property. Anything times 0 is 0, okay? So the whole point of this, we are factoring so that when we're set equal to 0, we can solve, okay? So this 30's got to come over. Have you thought of two numbers that multiply to negative 30 and add to negative 1?
Negative 6 and positive 5.
Negative 6 and positive 5. So x minus 6, x plus 5. Those FOIL out to x squared minus x minus 30. So if we set these equal to 0, then we know that x equals 6 and x equals negative 5. And here in a couple weeks, we'll talk about what we can actually do with those numbers. But right now, we just got to learn the process. Okay? This is me getting really excited. Factoring is like one of my favorite things, people. You are in for a treat.